Hello, in this video I'm going to explain you a little bit more about roots. So far we've seen that the square root, when we say the square, what we are saying is that the exponent is 2. We normally don't write it, it's 2. Why? Because 2 to the second, its exponent I have here is 4. But now I'm going to tell you that the square of root is also minus 2. Why? Because minus 2 to the second is minus 2 times minus 2. 2 times 2 is 4, and minus times minus is plus. So we have the same result. So when we have a square root, we have two options, the positive and the negative result. This is plus 2 and minus 2. But we write the signs together. The same thing, for example, with the square root of 9. It is plus minus 3, because 3 to the second is 3 times 3 is 9, and minus 3 to the second is minus 3 times minus 3. 3 times 3 is 9, plus minus times minus is plus, so we get the same result. So when we have here a number, and we have here the exponent is an even number, can be 2, 4, 6, like this, we will have two results, the positive and the negative one, okay? Now, what happens if the exponent is different? We have here a 3, the third root of 8. That means that here we need a number, a, let's say, so a to the third has to be 8. How can we get that number? What we have to do is we have to factorize a number, the number that is inside the root. What is factorizing a number? It is expressing it but using prime numbers. The prime numbers are 1, 2, 3, 5, 7, 11, 13, and so on, because these numbers can be divided just by themselves and by 1. For example, 2 by 2 and 2 by 1. For example, 4 is not a prime number because it can be divided by itself, by 1, but also by 2. So it is not a prime number. We don't get into account the first one, 1. We start with 2. So we must think, is it possible to divide 8 by 2? Yes, it is. We have 4. And now we continue. Can we divide it by 2? Yes, we can. So 2 as well. 2 again, by 2 and 1. When we get 1 here, that means that we have finished. So 2 is what? 2 times 2 times 2, which is 2 to the third. So now, instead of writing the third root of 8, I can write the third root of 2 to the third. As the roots and the powers are opposite operations, if I raise it to the same exponent that I have here in the root, that means that I'm doing something for not doing it. So I can remove them and we will get 2. Another example, we have the third root of 27. What we have to do is we factorize 27. It is not possible to divide it by 2 because it's not an even number, it's an odd number. And by 3, yes, we can divide it. It's 9. By 3 again, 3. By 3, 1. So instead of 27, I'm going to write it like 3 times 3 times 3, which is 3 to the third. So instead of writing 27, I'm going to write 3 to the third. So as both of the exponents are the same, we can remove them and we get 3. This is because when we have, for example, 5 and we multiply it by 2 and divide by 2, here the 2 is multiplying and here is dividing. They are opposite operations. So this is 5 times 2 is 10 over 2 is 5. We get the same number because they're opposite operations. It happens the same with the root and the power. As they are opposite operations, we can remove them.